You know who he is? Exactly, you're right. He is Isaac Newton and the proponent of Newton's law of motion. And for today's episode of Physics is Fun, we will discuss the first law and the second law of motion. Are you all excited? Let's go! First law of motion is all about law of inertia, wherein it states that an object at rest stays at rest and an object at motion stays at motion unless acted upon by an unbalanced force. However, the second law of motion, which is known as the law of acceleration, states that force is equals to mass times acceleration. And now let's proceed to the problem solving! Let's now start at problem number 1 regarding Newton's first law. At a carnival presentation, a guest joined the circus artists in their act. However, an accident happened. The guest was just able to cling into a trapeze pulled to the side by another circus artist. Compute for the tension of the two ropes if the girl is momentarily motionless and her mass is 80 kilograms. Include a free body diagram. Here in the illustration, you can see that this is tension 1 with an angle of 25 degrees and here is tension 2 with an angle of 15 degrees. And of course, this is the weight. In physics, visualizing problems is important for you to understand it really well and solve it properly. In any problem, we must find first what are the given quantities. In this problem, the only given is 80 kilograms, which is the mass. And then, what are we finding? Of course, the tension of the two ropes, which is T1 and T2. Let's now proceed at the free body diagram or the FBD. Here is tension 2 with an angle of 15 degrees. And here is tension 1 with an angle of 25 degrees. And of course, our weight. You might ask me, why did I put 25 degrees in here instead of putting it here? According to vertical angle rules, vertical angle are congruent. So we can put 25 degrees in here. It's also correct. Next, in this kind of problem, we need to identify first the vertical components and horizontal components of the tension. So, again, for review, this is the vertical component or the y-axis. And then here is the horizontal axis or x-axis. So this is y and this is x. Let's now proceed in identifying the vertical components first of tension 1. Vertical components of tension 1 would be this side. This will be T1y. And then the horizontal component of this would be this one, T1x. And then for T2, we have T2y. And of course, this one as T2x. But we can simplify that. According to trigonometry, when the angle is opposite to the horizontal component, that will be sine. If it is adjacent to the line we are pertaining to, we will use cosine. Like this, since it is opposite, we will use T1 sine theta, wherein theta is the angle, so it will be 25. And for this one, T1y, since it is adjacent, we will use cosine. This will be T1 cosine, again, theta, or the angle, 25. Moving on with tension 2. This will be cosine since the angle is adjacent to the line we are pertaining to. So it will be T2 cosine theta, or the angle. And then this will be sine, for it is opposite the angle. T2 sine 15. Let's now proceed at the formula and the solution. Summation of F net or net force is equal to 0. Proceeding to all the forces acting upon on the x-axis. What are those? Of course, are T1x or T1 sine 25. But I have a question. Is it negative or positive? If your answer is negative, you're correct, since it is on the negative x-axis. Again, for review, this is negative x-axis, positive x-axis. This is negative y-axis, and this is positive y-axis. Now, it will be negative, so it will be negative T1 sine 25 plus T2x. It is positive since it is on the positive x-axis. T2 cosine 15 equals 0. Let's make it positive, specifically this one. We just need to apply addition property of equality, or for others, transpose. It will be like this. T2 cosine 15 equals T1 sine 25. For convenience in this kind of problems, since there are still no known variable to us, we must exclude one. And in this problem, we will exclude T1 by dividing sine 25 to both sides. By that, we can cancel sine 25 here, giving us T1 equals T2 cosine 15 over sine 25. Let's move on now on the forces acting upon on the y-axis, wherein it is summation of forces on the y-axis equals 0. What are those? First, T1y or T1 cosine 25. This will be positive since it is on the positive y-axis. Again, plus T2y or T2 sine 15. It is positive again. And lastly, don't forget our weight, which is on the negative y-axis. Thus, its sign will be negative, equals 0. Let's make it all positive by using again addition property of equality, or what they call transpose. T1 cosine 25 plus T2 sine 15 equals weight. Weight became positive. And with this, we can now substitute the value of T1 to the T1 here, so that we can be able to identify tension 2. Watch and learn. This T1 will be T2 cosine 15 over sine 25. Let's also include this in the equation. Cosine 25, then copy this, plus T2 sine 15 equals weight. Since we have cosine 25 here and sine 25, in trigonometry, it can be simplified as 1 over tangent theta, since they have both 25 degrees angle involved. So we can simplify it. But if they have different angles, we cannot. Again, we can just simplify trigonometric identities that has the same angle. Otherwise, we cannot. So this will be T2 cosine 15 over tangent 25. Again, copy these quantities, plus T2 sine 15 equals weight. However, we cannot factor out yet tension 2. What we need to do is to multiply tangent 25 to both sides for it to be removed. leading us in factoring out tension 2. Let's do it. Multiplying both sides to tangent 25, it will give us this answer. It will be cancelled. T2 cosine 15 plus T2 sine 15 tangent 25 equals weight tangent 25. And that's it. We can now factor out tension 2. Tension 2 multiplied by cosine 15 plus sine 15 tangent 25. And we just need to copy this. Weight tangent 25. And now to have the answer in tension 2, we need to remove these quantities. And again, we will just divide. Divide both sides by those quantities. Cosine 15 plus sine 15 tangent 25. Also on the side, cosine 15 plus sine 15 tangent 25. And this will be cancelled out, leading us to tension 2 equals weight tangent 25 all over cosine 15 plus sine 15 tangent 25. And if we got this, we can now substitute all the numerical values. Remember, weight is mass times gravity. So in our given, we have 80 kilograms. So we will put 80 kilograms as the mass, and gravity, which is 9.8 meters per second squared. Tangent 25 all over cosine 15 plus sine 15 tangent 25. And if we solve that, it will give us an answer of 336.4440 newtons. Don't forget, for tension or force, our label will be newtons. But to finalize this answer, we need to follow the significant figures. Looking at our given, we have 3 significant figures. 1, 2, 3. So we need to follow that in our final answer. So tension 2 will just be 336 newtons. We will not round this up. The number before 6 is 4, which implies that 6 will remain. Let's not forget that we still have T1. We just need to substitute T2 in the T2 here so that we can have the tension 1. So tension 1 is equals to 336 newtons cosine 15 all over sine 25. And if we solve for that, our answer will be 767.9533. Again, following the significant figures, our tension 1 will be 768 newtons. And that is our final answer in this problem. Tension 1, 768 newtons, and tension 2, 336 newtons. It's easy, right? Let us now proceed with problem number 1 on Newton's second law. During a trip, Ron and Luisa's vehicle suddenly stopped. According to Ron's calculation, they need to accelerate at 2.67 meters per second squared at least to catch up with the nearest automotive repair shop before it closes. How much force must both of them exert to be able to achieve that? The mass of their small car is 189 kilograms. We need to identify what are the given quantities. So here we have acceleration, which is 2.67 meters per second squared, and the mass of the car, which is 189 kilograms. We need to find the force that both of them must exert to attain that acceleration. So we need net force. Let's now proceed to the formula and solution. In this kind of problem, specifically in Newton's second law, our formula will be net force is equals to mass times acceleration. Let's now substitute. Net force is equals to mass, which is 189 kilograms, multiplied by the acceleration, which is 2.67 meters per second squared. When we multiply that, that will give us 189 times 2.67. Our answer will be 504.63 newtons. Don't forget that the label in force is Newton. In finalizing our answer, we must be mindful about the significant figures of our given, because that will be our basis on the significant figure on our final answer. So in our given, we have 3 significant figures. Both of them have 3 significant figures. So in our final answer, we will use 3 significant figures. So this will be net force is equals to 500, round up or remain. If you answered round up, you're correct. This will be 505 newtons, since 6 implies to us that we need to add 1 in 4. That will make it 505. And this is our final answer in problem number 1 regarding second law of Newton. Let's proceed to another problem. Next problem regarding Newton's second law. A 75 kg volleyball player starting from rest acquired a final velocity of 8.50 meters per second in just 3 seconds. What was her average acceleration? How much is the force she exerted backward on the ground to achieve that acceleration? Again, let's find the given quantities. We have mass, which is 75 kilograms. We have final velocity, which is 8.50 meters per second, and the final time, which is 3 seconds. We need to find first the acceleration, and next is the force. In our formula, we need first to know what is the formula of acceleration. Acceleration is equals to delta V over delta T, which indicates that Vf minus Vi over Tf minus Ti. Again, Vf minus Vi over Tf minus Ti. Let's substitute the values. Since according to the problem, the player started from rest, so we don't have initial velocity and initial time, giving us acceleration is equals to Vf over Ef, which is 8.50 meters per second over 3 seconds, giving us the answer of 2.83333 meter per second squared. To finalize this, we need to follow the significant figures in our given quantities, which is 3. The significant figure in the given is 3, since all of them have 3 significant figures. So our answer will be acceleration is equal to 2.83 meters per second squared. Next, let's find the force. In force, our formula will be net force equal to mass times acceleration, wherein mass is 75 kilograms and acceleration is 2.83 meters per second squared. That will give us the answer of 212.25 newtons. Again, we need to finalize this according to significant figures, which will give us net force is equals to 212 newtons. And these are our answers. Acceleration 2.83 meter per second squared, and the force is 212 newtons.